Hi guys, I'm Bailey with My Math Experts, and today I'm going to teach you how to solve this problem. It's asking what are the solutions to the following equation. The equation is 2x squared minus 6x minus 8 equals 0. There's actually two ways that you could do this. I'll show you both ways and you can choose your favorite. You're gonna need to know how to do both of them anyway, depending on the problem. So we'll start with the long way, we'll say, which is method one. Method one. A lot of the times you're going to have to do this the long way. So it's good to know this. So this is in the form ax squared plus bx plus c. First of all, let me back up a second. You might be really tempted to try to solve this equation for x by let's move the 6x over to the other side. Let's move the 8 over to the other side. Let's try to get x by itself. The reason that's not going to work is because of this x squared term. So we have an x squared term and a linear x term, meaning x to the first. So if you try to get x by itself the normal way that you're used to with solving linear equations in like middle school, you're going to run into some trouble because we got an x squared and an x, and that's not something that you're used to. So instead, when you're working with a quadratic equation meaning the highest power of x is 2, you're going to have to factor first. If possible, some of these are not going to be factorable. This one happens to be. So I'm going to show you how to factor it if it's in this specific form, ax squared plus bx plus c. So for us, our a term is 2, our b term is -6, our c term is -8, and we're going to find two numbers that fulfill both of these conditions. They multiply to a times c. So for us, a is 2, c is -8. So for us, this is -16, 2 times -8. And add to b, and our b term is -6. So the easiest way to do this is to think about factor pairs. So like, what are some things that could multiply to -16, 1 and 16, like -1, +16, or +1, -16. Those are options. We got 2s and 8s. We got 4 and 4. And I think that's it. Okay, so now we have to see which of those pairs fulfill the second condition. They add to -6. This first one adds to 15, -15, +6, -6. Hey, we found it. And just to check, this one adds to 0. So 2 and -8 both multiply to -16 and add to -6. So that's part one. And if this was, if our leading coefficient here was a 1, we could just go ahead and split our pairs up handy dandy really easily. We could just say, oh, so this is x plus 2, x minus 8 equals 0. But unfortunately, if you have a leading coefficient here, this a term that is not 1, you have to go through a little bit of a longer process, because we can see if we distribute all this stuff back out. I'm just going to do this really quick as a check to show you why this doesn't work. We don't end up getting what we started with. We're missing the a term. So from here, we're going to do some kind of backwards work. So one of the criteria we used to come up with these numbers 2 and -8 were the fact that they added to -6, right? They added to b. So what we're going to do is actually, let me rewrite our problem here. We're going to split up this -6x into 2x and -8x. You can see all we're doing there is splitting up -6x into 2x minus 8x. And then we're going to do something pretty cool. We're going to do something called factoring by grouping. And that's a really fancy way of just saying factoring by greatest common factor, but we're only looking at the first two terms and the last two terms. And we're going to see what can we factor out of just 2x squared plus 2x. That greatest common factor is going to be 2x. And then what's left on the inside, once we divide 2x squared by 2x, we're going to have an x left over. 2x divided by 2x is going to be a 1. And then we're going to separately see what we can factor out of negative 8x minus 8. Looks like a negative 8 would do us pretty good there. We're going to keep our equals 0 here. And then we can do something that I think is really, really cool. We can undistribute this x plus 1, or factor this x plus 1 out of term 1 and term 2, so that we get x plus 1 times 2x minus 8 equals 0. And then, hey, look at that. Now we are perfectly factored. It's also really easy to check your work because you can just multiply everything back out. I won't do that just for the sake of time here, and you saw me multiply something out earlier. But if you would like to check this way, please do, especially when you're working on problems on your own. So now, unfortunately, we still are not done. These problems are very long and very complicated because we have to still solve this equation. We don't know what x values make this true yet. So we're going to use something called the zero product property. It basically just says if you have two things that are being multiplied together and they're equal to 0, then either the first thing has to be 0, so either x plus 1 has to be 0, or the second thing has to be 0. And then you can just solve these equations separately. So solving this first equation for x, we would subtract 1 on both sides to get x equals negative 1. And solving this equation, we would add 8 to both sides, divide by 2 on both sides to get x equals 4. So you get two values for x, negative 1 and 4. So this is method 1. It's really long, but unfortunately, if you have a situation where you have a non-1 coefficient here, this is often the way you're going to have to do it, especially if your teacher wants you to show your work and show all of the factoring. There's actually a third way of doing this problem that I remembered, but I'm not going to go through it. I'll just tell you about it because it's not usually what this skill is testing, method 3. But let's talk about method 2 really quick. I'm going to give us some more room here. And I'll do a different color to help differentiate. Method 2 here only works sometimes with very specific numbers, but when it works out, it's really nice. So method 2, check for GCF first. This is a really helpful strategy that is going to make your life easier if you are given problems where it is applicable. So for us, just as a reminder, our problem is 2x squared minus 6x minus 8 equals 0. And then, hey, wait a second. I'm noticing that all of my numbers here are divisible by 2. So I'm going to just go ahead and factor a 2 out first. Minus 3x minus 4. And then this is a much simpler x squared minus 3x minus 4. That is much simpler to factor because it doesn't have an a term that is not, that was a bad way of saying that. Its a value is 1 on that because the a value is just whatever comes in front of the x squared. And we just have a 1 there this time. So this is a lot easier to factor. To factor something like this, all you need to do is find two numbers that fulfill both of the following conditions. This is sounding familiar, isn't it? Multiply to, technically it's still AC, but A is 1, so it's not going to do anything. So we're just going to say multiply to C, which is negative 4. And add to B, which is negative 3. So multiplies to negative 4, that could either be positive 4, negative 1, negative 4, positive 1, or negative 2, positive 2. And then which of these add to negative 3? Let's check it out. This adds to positive 3, negative 3. Hey, we got it. So our numbers here are going to be negative 4 and 1. So what's really nice about this is there's no extra work after this. Your factor pairs are literally just x minus 4 and x plus 1. And again, you can check that by distributing everything out if you want to. And now this is really nice because same zero product property reasoning here. If things are being multiplied together, either 2 has to be 0, which it's not. We know 2 is not 0, so we can automatically get rid of that. One thing I want to note, if it's an x out here that you factored out, you do have to separately make an equation for that, and you could have like 3 solutions. But since this is just a number, it's 2. We know 2 is not 0. We don't have to worry about that. Or x minus 4 is 0, or x plus 1 is 0. Solve each of these separately. We're going to add 4 to both sides to get x equals 4, and subtract 1 from both sides here to get x equals -1. And I believe those should be the same answers we got from doing it the long way. Let's zoom out here and take a look. We got, -1 and 4. Great. So again, this is really nice when it works. There has to be a GCF that you can factor out to do this, though. And not always. If your numbers are really weird, if it's like, for example, 3x squared plus 7x minus 11 or something, there's no GCF there, and you're just going to have to go straight to the long way. So bear that in mind. Let me briefly touch on method 3, because I would be remiss if I did not mention method 3. Method 3 is our good friend, the quadratic formula. The quadratic formula will solve any problem, factorable or not. However, depending on your math class, your teacher might want you to show work knowing that you can factor. And key thing with the quadratic formula, it does not work with expressions. It only works with equations. So what I mean by that is if your homework question says factor x squared plus 9x plus 20, and you start using the quadratic formula, that is not going to give you an answer to this type of question. It only works if the question is saying solve this expression equals 0. Now this is an equation because it has an equal sign. Now you can use the quadratic formula with it. So be very careful with the quadratic formula. It's fantastic. I'll write it out here as a second just so you can use it if you want. But teachers can get kind of tricky about making sure you actually know other ways of doing it besides the quadratic formula. So that's why I saved it for last. That quadratic formula, if you want to use it, is this formula, -b plus or minus the square root of b squared minus 4ac over 2a. The other thing that I see students get into a lot with quadratic formula is calculator errors, especially if you're allowed to use a calculator. So I would just say be very careful with this. Take your time, simplify as much as possible before going to a calculator with this. And that is it. Thank you for hanging with me. This is a long one. One of the longest skills in Algebra 1. Nobody likes it. But if you practice, you'll get the hang of it really quick. And factoring is something that really doesn't go away. It keeps coming back up in future math classes. So it's really good to have just a solid foundation so that you don't have to worry about relearning it over and over and over again. Great. Thanks. Hope that was helpful.